Hi, welcome back to my channel pibyme Maths. This is Devan. Here we are solving May-June 2019 Pure Math 2 paper. In the previous video we have covered question number 1 to 5. Let's look at question number 6 now. We have a function given where k is a constant. X minus 3 is a factor of f of x. So you put x minus 3 is 0, so x is equal to 3. So when you sub in x is equal to 3 into the function, you should get 0 because there will be 0, the remainder will be 0. So replace x by 3, k times 3 cube, 15 times 3 square, 32 times 3 minus 12 is 0. That's basically 27k minus 9 times 15, 90 plus 45, 135 minus 96 minus 12 is 0. 135 plus 96 plus 12 divided by 27. Therefore, k is equal to 9. It's a 2 mark question. Part B now, fully factorize f of x. Okay, I'm going to write f of x now. Kx cube, so 9x cube minus 15 minus 32 minus 12. Okay, we know x minus 3 is a factor. So usually for questions like this, you take this function, divide the function using the divisor, using the long division method, right? And then find the quotient and factorize the quotient also. Okay, we have learned the method already, but I'm going to show you here another method. You can learn this method also. You write this 15x square minus 32x minus 12 as x minus 3, that's a divisor, times you put a quadratic function ax square plus bx plus c. That would be the quotient when you divide the function by this using long division method. How do I know it's quadratic? Because when you multiply, you get a cubic function. Now by comparing the coefficient of x cube on both sides of the equation, here the coefficient of x cube is 9, here it's ax cube, so we got the value of a. This is called comparing the coefficient method. You can find the value of a, b, c. I'm going to compare the coefficient of x square now on both sides of the equation. Minus 15 on the left hand side. If you multiply carefully, you will get bx square, so coefficient is b. Not only that, you have minus 3ax square also. So the coefficient of x square is b minus 3a. We know a is 9, sub in here, it's minus 27. Goes to the other side, 27 minus 15, b is equal to 12. And then you can also give any value in the place of x. I'm going to sub in x is 0, which is same as comparing the constant term on both sides. These are all 0, minus 12 is equal to, this is 0, so minus 3. These two are 0 times c. c is minus 12 over minus 3 is 4. So therefore this quotient is ax square plus bx plus c. So you need to write that and you need to factorize it again. So now I'm going to write this as 9x square plus 12x plus 4. Okay, and then factorize the quadratic again. 9, 12, 4. Minus 2 over 3 is the only value. X is minus 2 over 3. If you write it as a factor, it's 3x plus 2 times 3x plus 2. Or you can write it as 3x plus 2 whole square, that's all. Part C now. Solve for 0 to 360 this equation. Give your answer to one decimal place. This looks exactly like f of x. f of x is 9x cube minus 15x square minus 32x minus 12 is 0, right? It looks exactly like this. Only difference is in the place of x, you have cos theta. We factorized this function in the previous part, right? We factorize it as x minus 3 times 3x plus 2 whole square, right? So you can factorize this as x minus 3. X is cos theta. Cos theta minus 3 times 3 cos theta plus 2 whole square is 0, because it looks exactly like f of x. Equate it to 0 separately. You will get cos theta is 3. 3 cos theta plus 2 is 0. Cos theta is minus 2 over 3. We need to solve these equations in the given limit. Okay. The range of cos x is minus 1 to 1. So this has no solution. So you only need to solve this equation. So in the method I teach, when you have a negative number, you still take it as a positive number and find the principal value. That's the principal value. Use degree mode. Cos inverse of 2 over 3. 48.189. Do not round the figure. Immediately store it as A. Okay, now use the ASTC diagram, the cache diagram. The limit given is 0 to 360, which covers all the 4 quadrants, and you need to look for a quadrant where cos theta is negative, which is S and T. So 180 minus theta, 180 plus theta, that's the angle. Theta is a principal value. So theta is 180 minus 48.189, 180 plus 48.189. Round the answer to 1 decimal place. So 180 minus the principal value, I stored it as A. So 131.8 degree, and then 180 plus this 228.2 degree. We got 2 solutions already. Question number 7. Kim starts working for a company. In year 1, her annual salary is, the annual salary is 16,200 pounds. In year 2, it's not given. Year 3, it's not given, etc. etc. In year 10, the annual salary is 31,500. Model A assumes that her annual salary increases by same amount every year. When something increases by same amount every year, that's arithmetic. If it increases or decreases by same percentage every year, that's geometry. So find, according to the model, Kim's annual salary in year 2. They want you to find the second term. This is the 10th term. You can write it as A10 is 31,500. The formula is A plus 10 minus 1 times common difference is this. Make D as a subject. 31,500 minus 16,200 divided by 9. 1,700. We got the common difference. Now in the second year, first year plus the common difference, right? So year 2 salary is equal to 16,200 plus 1,700, which is 17,900 pound. That's all. So when you see a word problem from sequences and series, try to convert the word problem into a sequence or series and then apply the formula. Part B now. Model B assumes that her salary will increase by the same percentage every year. Okay, in year 1 it was 16,200. In year 2 we are not sure. Year 3 we are not sure, but in year 10 it's 31,500. Now it increases by same percentage every year, so it's a geometric series. So 10th term is 31,500. The formula for nth term is A times r power 10 minus 1 is this. So we need to make r as a subject. R power 9 is 31,500 divided by 16,200. 35 over 18, so R is equal to 9th root of 35 over 80. Okay, we're not interested in the value of R. We need the annual salary in year 2. That's the second term. So first term times R. So year 2 salary is the first year salary times R, 9th root of this. Okay, let me find the 9th root of the answer and let me store the value as A. That's a common ratio. So 16,200 times the common ratio, and they want the answer to be rounded to the nearest 10. So when you round to the nearest 10, that's 40. 17,440 is the answer. Part C. Calculate according to the two models the difference between the total amount that Kim predicted to earn from year 1 to year 10 inclusive. Okay. In year 1 it's 16,200. Year 2 we don't know. Year 3 we don't know. In year 10 it's 31,500. If we take model A, for model A it's arithmetic. So the first term is this. The common difference we calculated is as 1,700 here, right? So S10 is equal to, apply the formula, 10 over 2, n over 2, 2a plus 10 minus 1 times d. Or you can use the formula n over 2 times a plus l also. So that's basically 2 times 16,200 plus 9 times 1,700. Get the answer, times it by 10 over 238,500. Okay, for model B now, S10 is okay. The first term is the same. The common ratio is, it was 9th root of 35 over 18. We stored the value already, so you don't need to worry about it. S10 is A times R power, what's the value of R? The stored value, 1.076. Okay, never mind, can leave it as it is. 1.07 dot 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 forward 10 minus 1 divided by R minus 1. You will get this value and find the difference. Okay, 16,200 times R, I stored it as A, R power 10 minus 1 divided by R minus 1. Okay, 231019 point. I'm not going to round the figure. We will round the figure at the end. So I'm going to find the difference between these two. So this minus 238,500. This minus 238,500. The answer is 7 point. Okay, they want you to round it to the nearest 10. So that's basically 7480. When they say difference, you need to take the bigger number minus smaller number, or just subtract anyhow. If it's a negative number like this, ignore the negative number. That's all. Question number 8. Find the exact solution of this equation. That means we need to make x as a subject, but they want us to write the answer in this format where a and b are constants. Okay, I'm going to take logarithm both sides. So it's log 8 power 2x plus 1 is equal to log 6 put to the base 2. By applying laws of logarithm, we can put this in front. So 2x plus 1 log 8 to the base 2 is, I can write 6 as log 6 as log 2 times 2 3s are 6, right? So it's a log 2 plus, log 6 as log 2 times 3, and apply the laws of logarithm, it's log 2 log a plus log b. If you are wondering why I'm doing that, in the answer we have log 3, not log 6. Okay. If you put it in your calculator, 2 cube is 8, so log 8 to the base 2 is going to be 3. So 3 times 2x plus 1 is, log 2 to the base 2 is 1 plus log 3 to the base 2. Make x as a subject now. So when you open the brackets, 6x plus 3 is 1 plus log 3 to the base 2. Bring the 3 to the other side. 6x is 1 minus 3. Divide every term by 6. Minus 2 over 6 is going to be minus 1 over 3. Plus 1 over 6 log 3 to the base 6. And it looks exactly like this. They did not say a and b are integers, so it can be fraction also. A is minus 1 over 3, b is 1 over 6. That's a 4-mark question. Let's move on to part B now. Part B is solving logarithmic equation. So step 1, push all the logarithms to the same side. Log 7 minus 2y minus 2 log y plus 1 is equal to negative 1. The base is 5. And combine it to a single logarithm. You can put this 2 as a power, y plus 1 whole square, and log a minus log b is log a over b, y plus 1 whole square. I hope you understand this step. So you need to combine it to a single logarithm. That's the next step. And then get rid of the logarithm by rewriting using power. You can write this as 5 power minus 1 is 7 minus 2y over y plus 1 whole square. 5 power minus 1 is 1 over 5 is 7 minus 2y divided by y plus 1 whole square, which is this. Cross multiply. So 1 times y square plus 2y plus 1 is 5 times this, 35 minus 10y. Push all the terms this side, you'll get y square plus 12y minus 34 is 0, which is a quadratic equation. We need to solve the quadratic equation. Go to quadratic. 1, 12 minus 34. Okay, we are getting a third form, so you need to show this step actually. Y is equal to minus b plus or minus square root of b square minus 4ac, the quadratic formula, over 2a. So y is equal to minus 6 plus or minus square root of 70. Okay, you cannot leave it like this, you will lose a mark, because you need to sub in the values here and make sure all the logarithms are positive. So what I'm going to do, I'm going to check what's the value of this. Minus 6 plus 70 is a positive number. 2 point something, 2.4, right? When you sub in 2.4 here, 7 minus 2.4 is a positive. This also positive. So that's one solution. Minus 6 plus square root of 70 is a solution. And then the second one is minus 6 minus 7, that's a negative number, minus 14. The moment you sub in here, you get a negative logarithm. As long as one logarithm is negative, it's not a solution. So the substitution part and all you don't need to show. You can just write finally, therefore y is equal to minus 6 plus square root of 7. You don't show this, you leave like this, you're gonna lose more. Question number 9. Show that this equation can be written in this form. So I'm gonna take the whole equation. Cos theta minus 1 is equal to 4 sine theta. I'm gonna replace tan by sine over cos. That's the identity, right? Multiply through it by cos theta. So I will get cos theta times cos theta minus 1 is equal to, here the cos will be cancelled. I will get 4 sine times sine square. Open the bracket, you will get cos square theta minus cos theta is, you can replace sine square by 1 minus cos square using the identity cos square plus sine square is equal to 1. Now open the bracket and move everything same sign. Now when you move everything to this side, 4 cos square plus cos square, 5 cos square minus cos minus 4 is 0. We got the equation already. The next part, they want us to solve this equation. In part A, we got cos theta minus 1 is equal to 4 sine theta tan theta, and we have rewritten this equation as 5 cos square minus cos theta minus 4 is 0. That's part A, right? Now if you compare these two equations, what do you notice here? What has changed? It's the same equation, only thing in the place of theta you have 2x, right? So if you can rewrite this equation into this form, you can rewrite this equation into the same form, but you need to have 2x in the place of theta. So 5 cos square 2x, you don't need to show any working, you can straight away write this, minus cos 2x minus 4 is 0. You don't need to show all this working, which is a quadratic. I'm going to solve it now. 5 minus 1 minus 4. 1 minus 4 over 5. Cos 2x is 1. Cos 2x is minus 4 over 5. Write it as a factor, cos 2x minus 1 times 5 cos 2x plus 4 is 0. Don't skip that step. Now we have two equations, we need to solve them in this limit. Okay, I put the two equations here. The limit given was 0 to pi over 2, but since it's a harder trigonometric equation, we need to multiply the limits by 2. So it's 0 to pi. Okay. Now cos inverse of 1 is, cos 0 is 1. So 2x is equal to 0. X is equal to 0. You can consider this as a solution because 0 is also included in the limit, even in the original limit also it's included. If there is no equal sign here, you cannot take 0 as a solution. Okay, now let's solve the second equation. 2x is equal to, in the method I teach, you find cos inverse of the positive number, ignore the negative. Use radian mode. Cos inverse of 4 over 3. That was 4 over 3 or 4 over 5 actually. 4 over 5. 0.2x is 0.643 dot dot dot. That's just the principal value, not the final solution. So store it as A. Use the CAS diagram or the AES-TC diagram. The limit 0 to pi covers these two quadrants, and we need a quadrant where cos theta is negative, which is this. So it's the angle here is pi minus theta. So it's 2x is equal to pi minus 0.643. Get the value, divide by 2, and they want you to round it to 2 decimal place. It's pi minus a, I store the values a, divided by 2. Round it to 2 decimal place, you are going to get 1.25 radians. You can finally write therefore x is equal to 0, 1.25 radians. Two solutions actually. Question number 10 now. We have a diagram given, a graph given with two x-intercept P and Q. Let's read the question. Figure 1 shows a sketch of part of the curve C with this equation f of x. Using calculus, find the range of values for which the function is increasing. The condition for increasing function is f dash of x is greater than or equal to 0. So you need to differentiate it. First write f of x as 36x power minus 2 plus 2x minus 30. So f dash of x is 36 times minus 2x power minus 2 minus 1 plus 2 is greater than or equal to 0. This is basically minus 72 over x power positive 3 plus 2 is greater than or equal to 0. Push this number here. Minus 72 over x cube is greater than or equal to minus 2. Multiplied by x cube, we don't need to flip the sign of the inequality because x is a positive number. So minus 72 is greater than or equal to minus 2x cube, which is same as minus 2x cube is less than or equal to minus 72. Divide both sides by negative 2. So you need to flip the sign. Minus 72 over minus 2 is 36. So x is going to be greater than or equal to cube root of 36. That's the answer for part A. Part B, they want us to integrate it now. Okay? So you can write it as integral 2 to 9 36x power minus 2 plus 2x minus 13. Or they want us to show that it is equal to 0. So when you integrate it, 36x power minus 2 plus 1 over minus 2 plus 1, 2x becomes x square, 13 becomes 13x, 2 to 9. Now let's write this as minus 36 over x plus x square minus 13x, and then sub in the limit 2 and 9. So when you replace x by 9, minus 36 over 9 plus 9 square minus 13 times 9 minus sub in the lower limit minus 36 over 2 plus 2 square minus 13 times 2. Okay, minus 36 over 9 is minus 4 9s or 36 plus 9 square minus 13 times 9 minus 40 minus lower limit 36 over 2, minus 36 over 2 is minus 18 plus 2 square minus 13 times 2 minus 40. You don't need to actually write this step, you can straight away write 0. That's all, it's a 4-mark question. The next part C. The point P and Q lie on C. P of 2, 0, Q of 6, 0. Okay, this x coordinate is 2 here, x coordinate is 6 here. Okay. Now, given the 2 to 6, this one, when you integrate the curve from 2 to 6, you will get this area, right? It will be a negative number, that's minus 8, which is given here. State the value of 6 to 9. Okay. In the previous part, we have proved 2 to 9, the same function, is equal to 0, right? That's what we proved in the previous part, part B, right? You can split the integral into integral 2 to 6, this function dx, plus integral 6 to 9. You are allowed to split this way. So 36 over x square plus 2x minus 13 dx is 0. Right? And we know this value is minus 8. The value of this is minus 8, goes to the other side. Therefore, integral 6 to 9, 36 over x square plus 2x minus 13 dx is equal to positive 8. Because this negative 8 comes here, you'll get positive 8. That's all. Let's move on to CII now. CII, this integral from 2 to 6 is equal to 0. We need to find the value of this k. So let's integrate it. It becomes 36 x power minus 1 over minus 1 plus x square plus kx 2 to 6 is equal to 0, which is basically minus 36 over x plus x square plus kx. Sub in the upper limit, minus 36 over 6 plus 6 square plus 6k. Sub in the lower limit, minus 36 over 2 plus 2 square plus 2k is 0. Simplify this is minus 6, 36 minus 6 is 30 plus 6k. This is minus 18 plus 4 is minus 14 plus 2k is 0. When you simplify the like terms, 6 minus 2k is 4k, 30 plus 14 is 44 plus 4k is 0. Make k as a subject. Minus 44 over 4, k is equal to minus 11. That's all.